nice directions to this. This was a nice, yours has a little bit more than mine does. I don't know what happened to this. This is an isosceles triangle. And this is the base. And these are the base angles. Yeah. He said that it was probably impossible for you to do it. I would probably assume that that was a vertex since it was only written once. But if you draw an isosceles triangle and you're finding the height, if you remember back from geometry, the altitude bisects the base in half, and your two sides of your triangle are congruent, and your base angles are congruent. So it makes a nice little right triangle. By cutting the base in half, that would be the 4, that would be the 52, and you had to find the height, the x. I didn't expect you to figure that one out. My directions weren't even there. So, then you just use your tangent function. Okay, when you do this, make sure your mode is in degrees. Stop me if you have any questions. That one was probably like impossible to do if you didn't know what it was. An angle of depression. An angle of depression works the same as an angle of elevation. When you're standing at the horizon and you elevate your eyes, there's your triangle, there's your inside angle. Your angle of depression says you're standing at the top of something. This is your line of sight. When you depress your eyes, you look down, there's your angle of depression right here. But it's outside the given triangle. So here's their angle of depression. Here's their line of sight. Here's their angle of depression. Now you have a couple of ways you can build this. If you drop your triangle like this, this right here is the same as that one because they're two parallel lines cut by a transversal. So they're alternate interior angles. The angle of depression is congruent to the angle of elevation of the other angle. If you did that, this was a 90, then you could subtract this, use this angle, or you can build your triangle out here, do it that way. There was a number of ways you could do this. Because it's still 4,000 feet, you're still finding your depth. Still a right triangle. I think they're harder once you have to draw them rather than see them. Are you okay with this? Alright, so you're finding the missing side, the height, and you have a hypotenuse, and you have the angle, so you're looking at a sine function. Yes?
I did the same thing, but I did that nowhere near.
Did you set it up this way? Is your calculator in degrees instead of radians?
I didn't check.
What was your answer?
335.
It could be that you were in radians and not degrees.
Why do you put it into the calculator?
You put it in like this. You say cross multiply this. 4,000 times the sine of 31.5. But this has to say degrees.
Yeah, because when I put it in like that, it came to like an error.
Came to an error?
Yeah. So then I put it in like the sine -1. And that's what I got 335.
Oh no, don't do the sine -1 because that's when you look for an angle. The inverse is when you look for an angle. Let me switch my mode to radians. 335, you were in radians.
Okay.
I just changed the mode to radians. You were in radians. It's oddly enough when kids take the regions, if they have their calculator in the wrong thing and they get a negative, they erase the negative sign. And I would always tell my kids, if you get a negative on an angle, something's wrong. It's probably your radians. Okay, this probably would have been a little bit better explanation of an isosceles triangle. The front of an A-frame cottage, it makes an A, is an isosceles triangle. It stands 28 high, there's the altitude, 20 across, there's the base. What is the angle of elevation of its roof? So the angle of elevation has to be here. That's technically like the roof part here. So how far is it elevated? There's your angle of elevation. Doesn't matter which side you find, they're both the same. So remember the isosceles cuts the base in half. So God bless you. So here's your basic little triangle. 10, 28, and I don't know my angle. This is when you use the inverse. This is when you use tan negative 1. Find me an angle. This is the inverse. Find me an angle whose ratio is 20 of the tangent is 28 over 10. That's the second tan. That's the inverse. And it didn't say where to round to, so wherever you rounded to was fine. Usually go 3 decimals if it doesn't say. So they're kind of the same.
Wait, why did you change the negative 1?
Because you want to find the angle. If I have an angle, I say tangent angle. If I need to find the angle and I just have the ratio, I say second tan, whatever this happens to be. This is my ratio. This is my trig ratio. If I know the ratio but not the angle, I use inverse. Second tan. If I need to find the function, tan, sine, cosine, I just say sine 30, tan 30. Okay? Good? Alright. This one also kind of gave you the triangle. It was an elevation for a car coming up and down a mountain. And the hypotenuse of that right triangle is 4 miles. They didn't know the elevation. So here's your base. They kind of drew it. Here's your elevation. How much is it elevated? There's your x. And that little thing in there is your 9.5 degrees. So again, you have an opposite side and a hypotenuse. You have a sine. And your elevation should not be so big because otherwise you'd be carving like this instead of like gradually going up. Probably be scarier coming down than coming up. Did any of you try these? No? These were nice. Well, you were in radiance, so you probably had a little confusion there. Now, this was the tricky one. This was like yesterday's. Now, the angle of elevation is the same as your angle of depression. Or you can just build your 2 triangles like this and use that as your angle. This is 350, whether it's here or here. So it doesn't matter which way you did it. Now, yesterday we were looking for the side, and we had the smokestack. Turn the paper upside down. You share a base. You share the base, and the hypotenuse here is changing. So this is the piece that's a little bit different. And when you build your right triangles, let's see, you got one. Take them apart. Here's your one, and then here's your other one. Oh, wrong. This is a 65, and we don't know how far they are away from each other. This is the piece we want to find in here. So again, call one x, call one y, and subtract the pieces. It's just the opposite look that we did with the height of the smokestack. It's just the opposite look. You're sharing the same side. So that's what's similar. Before we found your side. Now you're finding your base instead. You still have 2 right triangles. Turning the paper upside down, it probably would look a little bit better. Just try to visualize where your triangles are and how far apart your shapes are. Usually when the algebra regents does this, they make you do a log sines, log cosines. But we just kept it real simple, right triangle trig. Usually they gave you the side in between or something. You had to find the side in between using your non-right triangle trig and then back it up from there. But this is just basic trig functions. And it's kind of the same approach as yesterday. I called mine a y and z. So I called this guy z. And I call this guy y. My times x, the distance in between. You have no other way to find this. Okay. Questions? That was a tough one. This was the last one, right? Reference angle. Where do I find a reference angle? In a quadrant. And very good. And I make a bow tie. And these are my reference angles in here. Right? My reference angles are from the terminal side of the angle to the x-axis. I wear a big bow tie. So what quadrant does 252 fall in? Three. This is 180. What's this guy down here? 270. Now, your reference angle, everybody makes a bow tie up here. This is your reference angle. Think this out. How far past 180 did I go to get to 252? 72. 252 minus 180. My reference angle is 72 degrees. That triangle will be the same in every quadrant. Do we have a special triangle for this? No, but that's just asking what your reference angle is. In terms of gradients, if this denominator is 5, this is 5 pi over 5, and what is this side? 10 pi over 5. I'm going in the opposite direction. I'm going clockwise. What quadrant will I terminate in? What? Second quadrant. I'm coming here. Look, here's 5. Here's 6. I drop a triangle to the x-axis. 5 goes into 180 how many times? 6, not 60. 36. 36? This is 36 degrees. 4 pi over 5. It's got to be 1 pi over 5, right? When it's, no matter where this is, this will make a bow tie. So you could say pi over 5 is your reference angle, or 36 degrees. Good? Here's an interesting one. I want you to think about this for a minute. This is 3 pi over 3. This is 6 pi over 3. I'm opening up counterclockwise. Where does this terminate through 17 pi over 3? Like twice, so that would bring me to 12. This would be 1. This would bring me to 12. This would bring me to 15. This would bring me to 18. So where's 17? 4. Okay, what's my reference angle? 3 goes into 180 how many times? 60. 60 is my reference angle. Oh, 60 is my special triangle. What's the side opposite 60? Radical 3. What's the side opposite 30? 1, 2. Good, special triangle. Remember those? Okay. All right. So sometimes we can go on and go through them. We should be pretty good with this, right? Did you find the missing side of a right triangle? Pythagorean's theorem. Guys, missing side of a right triangle, Pythagorean's theorem. Can you find all the other pieces? Anybody have a question on these two? Just do one? All right, so Pythagorean's theorem says, and if you want, put this in quadrant 1 if you want to use your x, y, and r's. So 9 squared equals 4 squared plus b squared. Subtract 16, and what does this give us? Now, if you can reduce this, you reduce this. But if not, then x is 4, y is radical 65, and r is 9. Or opposite, you can do adjacent, opposite, hypotenuse, because it's just a regular triangle. Can you find all your parts? Sine, cosine, tangent, and reciprocals? Yes, we can. Sine of theta is y over r, or if you did opposite over hypotenuse, radical 65 over 9. Cosine, x over r, or adjacent over hypotenuse, 4 over 9. Tangent, opposite over adjacent, or y over x, radical 65 over 4. And then the reciprocals. Can you find your reciprocals? Flip them over. That you should be able to do those.
Wait. 4 over, what's the cosine? 4 over x?
9. Radical 65 over 4. Do you see kind of a pattern? Both your sine and your cosine are over your hypotenuse, or your radius, which is 9. And your tangent uses the x and the y, doesn't use the 9. Right? Okay. Alright, let's hit this part. Find the angle in standard position. So let's go to this guy. What quadrant is the point -4, -6? Third, -4, -6. So it's on my circle, this point, and I have an angle that comes across here and terminates right there. This is the x, this is the y. I drop a triangle, make a bow tie to the x-axis, and I label my pieces. 4, 6. And I have to find my missing part. How do I find my radius? Out there, what's confusing? Oh no, your circle is imposed on it's superimposed on your XY axis. That's all we did. We did this. We found this point. -4, -6. Look. We said we have an angle that terminates at this point. Passes through the given point. So watch, my angle starts here and comes here and stops. Just like that, at that point. All your triangles go to the x-axis, we make a big bow tie. We drop the triangle to the x-axis. Label it like this. This is x, this is y. This is the x, this is the y. You need to find me the r. You have an x, you have a y, and you need to find me the r. If you want, you can put the negative signs there. I usually don't put the negative signs on my triangle. Choose your distances, but if you want to make a box out here, but if you want to put the negative signs there, that's fine. Just be careful in Pythagorean theorem that you don't square like this without the parentheses, or you're going to be in trouble. So this will be 16 plus 36, 52. This 52 can be reduced. Divide by 2, divide by 3, divide by 4. 4. And 13. So 2, radical 13. So look, here's all your parts. Can you do the rest? Now be careful, because you're going to have to reduce. Now here's a good trick, watch. Here's a good trick. You can reduce all of these by a factor of what? 2. Reduce them all first by a factor of 2. Reduce everything by a factor of 2. Because if I take the cosine, x over r, don't I have to reduce this? If I take the tangent, y over x, don't I have to reduce that? If I take the sine, y over r, don't I have to reduce that? So a shortcut is reduce everybody by 2. So x is -2, y is -3, and r is radical 13. and then just do your functions there. You don't have to reduce them later. All your trig values have to be reduced to lowest terms. So reduce them right up front. As long as you can divide 2 into all of them, not just 2 of them. If you use your signs out here, your negatives and positives, everything will work out fine. Your sine will work out negative, your cosine will work out negative, your tangent will say negative divided by negative, positive. So all your signs will work out fine. We give you a function and where your angle is located, and then you have to find the rest. So, secant is the reciprocal of which function? Cosine. Cosine is positive here. Tangent is negative. What quadrant is cosine positive in? First, fourth. Okay. What quadrant are tangent is tangent negative in? Second, fourth. Tangents are always opposite each other. Oh, where do they overlap? So I have a triangle here, drawn to my x-axis in the fourth quadrant. If it helps you and you'd rather use the cosine of this angle, take its reciprocal. X over r. If you can reciprocate it in your head, r over x. So I've got an x of 5, I have an r of 6. How do I find my y? Pythagorean theorem. Be careful on this guy because you're looking for a side. Subtract 25. And y is radical 11. And in this quadrant, is the y positive or negative? Look at your xy axis. You're down here. Negative. So don't even have to think. Just follow your axis. You're superimposed. You're right on your axis. That's why your x and your y's behave that way. So now that you have all your pieces, can you find your sine, cosine, your tangent? Sine y over r. Cosine x over r. Tangent y over x. You don't have to rationalize anything. And then find your reciprocals. Can you just flip them and find your reciprocals? Did our positives and negatives work out okay? Isn't the sine the only one that's negative there, and the tangent? Cosine is positive. The reciprocals behave the same way. So you had to locate what quadrant this was in. You had to drop a triangle given your 2 pieces that you had. Your third piece is the Pythagorean theorem of your right triangle. Sometimes you're looking for a hypotenuse, sometimes a leg, so be careful. Once you find this, do your information box. Do you guys find that helpful to do your information box? Like, I find that really helpful for me. I never have to think about who's negative, who's positive. Okay? Alright. This guy down here, here's your special triangles. So let's see where these angles are located. Denominator 3, 3 pi over 3, 6 pi over 3. What quadrant do I find that in? First. I only got 1 pi over 3. I'm in the first. 3 goes into 180 how many times? 60. Now, label your triangle. Any which way you remember. What's opposite to 60? Radical 3, opposite to 30. And radius, hypotenuse, 2. So, x is 1, y is radical 3, r is 2. So the tangent is y over x. Radical 3 over 1, and reduce this back to radical 3. Don't leave it over 1. While we're here with the 3's, where do I find 5 pi over 3? fourth, I'm 1 less than 6, right? Is everybody okay with finding those? Using this method, this works so much easier. You don't have to convert anything in your head. You just follow it. Make this the same, make this doubled, or whatever your denominator is. It doesn't matter if it's 7 in your denominator. Okay. So come here. We still make a triangle. This is a reflected triangle. The sides are exactly the same, except my x is positive. My y now is negative. The only thing that's going to change, I'm going to get the same thing, but my tangent now is going to say negative radical 3 over 1. The value itself can't change. It's a congruent triangle. It's just reflected over that axis. Can everybody just put these in your calcs? Yeah? Okay. Alright. Let's jump to this one. How many do we have? Okay, good. Let's jump to this guy. Find two values of theta in degrees from 0 to 360. That means I want to look anywhere in this circle. And I want to give my answer in radians as well. Now, any values, where is cosine negative? 2 and 3. But the triangles have to be the same, don't they? Anybody recognize what reference angle this is? If your cosine is radical 2 over 2? Not a 35. 45. Unrationalize this guy. It would be this guy. So this is x over r. 1, radical 2, 1. So it's in the same in both quadrants. So your reference angle is 45. Now, I want this angle from here to here. Let's do it in degrees first. It stops 45 degrees short of 180. So 180 minus 45. 135. Then it goes here and goes past 45 past 180. Here's your 45 angle. It went 180 and 45 more. Add it in your calculator. 180 plus 45. 225. Okay, let's do this in radians. How many times does 45 go into 180? 4. So this is 4 pi over 4. And this is 8 pi over 4. What's 1 less than 4 pi over 4? 3 pi over 4. What's 1 more than 4 pi over 4? 5 pi over 4. There's your angles. Radian is probably easier for you to do if you catch the finding what that bottom number is. Okay, let's try this one. This is important. Cosecant is the reciprocal of which one? Sine. Okay, what quadrants is sine negative in? 3 and 4. So drop 2 triangles. They have to be exactly the same, don't they? So I don't really like to deal with this, so let me flip this over and let me do the sine of this angle. Negative 1 over 2. That one should ring a bell, right? The cosecant didn't ring a bell, but that one rings a bell for me. Y over r. 1, 2, what's this missing side? Radical 3, what's this angle? Opposite the 1. 30. Now, you're going to come 180 and then past 180, 30 degrees. Wait, how many degrees? So you're 10. You're going to come over here, but you're going to stop short of the 360 by 30 degrees. 330. Okay, how many times does 30 go into 180? 6. 6 pi over 6. 12 pi over 6. So if I go 1 past the 6 pi, what am I? 7 pi over 6. If I'm 1 less than the 12, what am I? 11 pi over 6.